Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be talking about chemical families. And our subtopic today will be on alkaline earth metals. So, initially, we talked about alkaline metals or alkali metals. So, today we are going to do a different family. So, we look at the introduction of alkali metals, what they are, and what are their sizes, and then afterwards, you get to do a few questions. So first you start with what alkaline earth metals. These are elements with two valence electrons on the outermost electron. That is the reason why they are usually grouped in group 2 of the periodic table. And they're usually metallic in nature, just like in our counterparts alkali metals. And they're usually consisting of beryllium, magnesium, calcium, strontium, barium, vanadium. So when you look at them in the periodic table, they appear in group 2, as you can see. We have the beryllium, magnesium, calcium, strontium, barium, and radium. So we are not going to be discussing on strontium, barium, and radium. You'll hear barium being mentioned, but you're not going to go into details. What you'll be looking at are the first three, that is calcium, beryllium, and magnesium. But you can see where they are. They are in group 2 of the periodic table. So when you look at the arrangement, you can see beryllium is 2.2. If you were to draw the dot and cross structures, it would be like this. So it has two energy shells. So the first shell has 2 electrons, while the second shell has 8 electrons. Remember, you can use dots and crosses, it's still the same. Then our magnesium is 2.8.2. So it has 3 energy levels, unlike our beryllium that had only 2. So the first shell has 2 electrons, and then the third shell has 8 electrons. In this case, now we have used the dots, so you can use them interchangeably, not inside the same atom, but in a different atom altogether. Make sure your circles are neat. And then finally, we have calcium with 4 energy levels. So the first shell has 2 electrons. So you can see how interesting my circles are. Make sure yours are better. You can practice. The second shell also has, the third shell that is, has 8 electrons as well. And finally, the last shell, which has 2 electrons. So you can see the way they look like in the dot and cross. So this brings us to the next. We are going to look at their graduation in some of the properties. And one of the things to look at is the size. So the atomic radius, we said it's a distance between the center of the nucleus of an atom and the outermost energy level. And then for the ionic radius, it's the distance between the center of the nucleus of an ion, see the difference, and the outermost energy level occupied by electrons. So if you look at the graduation of these sizes, you notice the ionic radius and the atomic radius also increases down the group, just like in alkali metals. And then the reason why they increase is because there is an increase in the number of energy levels down the group. If you were to show an example, we can look at our previous example that we did previously. You can see the atomic radius down the group is increasing even from these two images. This is because you can see in beryllium we have 2 shells, in magnesium we have 3 shells, in calcium we have 4 shells. You can see there is an extra shell as you go down the group. That is the reason why the atomic radius increases down the group. As for the ionic radius, we know that beryllium reacts by losing 2 electrons, so the new ionic configuration will be 2. Then magnesium also reacts by losing 2 electrons, so the new configuration will be 2.8. And then calcium also reacts by losing 2 electrons, so the new configuration will be 2, 8, and 8. So this is for the ion configuration. So if you look at the sizes of the ion, you notice also they are increasing down the group. Beryllium will have 1 shell, magnesium 2 shells, calcium 3 shells. So there's an extra shell down the group for the ions. Next, you look at the atomic and ionic radius of the same element. So if you were to compare the sizes between the atomic radius and the ionic radius of the same element, you notice that the atomic radius will always be larger than the ionic radius. This is because alkaline earth metals, they form ions by losing the valence electron, which causes or leads to the loss of the entire outermost energy level. So the atoms have more energy levels than the corresponding ion. For example, if we were to look at calcium, we have the configuration of calcium is 2.8.2. When calcium loses 2 electrons, the ionic configuration becomes 2.8.8. So you can see we have 4 shells in the atom, but in the ion we have 3 shells. So that is what we refer as we are losing an entire outermost energy level. And for another reason, you notice that the ion has more protons because it has already lost 2 electrons in the outermost energy level. If it has more proton, there is an increase in the nuclear attraction. This pulls the outermost energy level closer to the nucleus even more. It pushes them even harder. There is an extra 2 protons in the nucleus, because you see initially we had in the neutral atom we had 12 electrons and 12 protons, but you notice they cancel out, like they make it to be neutral. But in the ion we have 10 electrons and 12 protons, so you can see we have 2 extra protons that are not able to balance out. So this causes the increase in the nuclear attraction, which pulls the outermost electrons closer to it. So if you look at the general sizes, you notice the atomic radius, you can see from the image, is increasing, and also the ionic radius is increasing from beryllium to calcium. So let's look at a few questions. The atomic radius of alkaline earth metals are smaller than those of the corresponding alkali metals of the same period. Explain. So atomic radius of alkaline earth metal are smaller than those of corresponding in the same period. So this brings another concept. You're going to look at this concept later on in detail, but I'm going to mention it. For example, if we look at sodium, which is in group 1, and then we look also at magnesium. So if you look at sodium is 2.8.1, if you look at magnesium is 2.8.2. They are on the same period because they have the same number of energy shells. But if you look at the outermost shell, they tell you this is in group 1 and this is in group 2. So you are being told the atomic radius of the alkaline earth metal, this is small and this is large. So there's a concept here we are going to learn later on. This concept is on period 3 elements. So we are going to say that the one that is in group 2 has more protons. And you can see why. Sodium has 11 protons in the nucleus. And then magnesium has 12 protons in the nucleus. So you would expect magnesium to have a higher nuclear charge or attraction. So it will attract the outermost electrons closely, causing it to be very small. So we are going to discuss these details later. Just remember, you can try to also get more on this, but it's all about the number of protons. The number of electrons, yes, are increasing, but their effect is very negligible. That is what we are going to say later on. and then states and explains the trend in the atomic sizes down the alkaline metal. So the atomic sizes increases down the group because there is an increase in energy levels down the group. And also we said in this case, you're not going to talk about the increase in the nuclear attraction because you're not talking about the ion. Atomic radius of magnesium is larger than the ionic radius of magnesium ion. Explain. So this is where the explanation comes in. First of all, the magnesium atom has an extra energy shell than the ion, and when magnesium loses an electron, there is an increase in nuclear attraction that pulls the electrons closer to the nucleus. Thus, the ion will be smaller. So what we look at when we are getting the answers for this question is, first of all, we need to see the sizes, the amount of the shell in both ion and the atom, and also we need to see the how much the outermost electrons are being pulled closer to the nucleus as a result of the increase in the nuclear attraction. Some other books will talk about the nuclear charge is still okay because it becomes more positive. So those are the questions for this session. So next session, we are going to dive deep into some of the physical properties. So see you then.